Hey guys, so the question that is there in front of you on the screen is taken from JEE Mains 2024, and I would say this is one of the best questions that appeared on JEE Mains in 2024. It is a very conceptual, very tricky question, and doing these kind of questions really strengthens your concepts. So let us go ahead and solve this question. But before we go through the solution, I would strongly recommend you to pause this video at this moment and give this question a try. Okay, so what do we have? So we have a function f which maps from real numbers to real numbers, and it is thrice differentiable, all right, such that f of 0 is equals to 0, f of 1 is equals to 1, f of 2 is minus 1, f of 3 is 2, and f of 4 is minus 2. So all these values are given, all right. Then the minimum number of zeros of this function. So we have to find out the minimum number of zeros of this function. Okay, before dealing with these values, so let us first consider this particular function and see what it is. So you are given 3 times f dash and f double dash. F double dash is the second derivative of f of x plus f into f triple dash of x. This is the function given to you. So the moment, like, it is a weird looking function, but the moment you look at it, you have to, like, this is the idea that you should get. This is how your thought process should be. The main motto of making this video is to, explain you how to think when you encounter these kind of questions. All right. So what do you see here? So you see the product of two functions, and one function is the derivative of the other function. All right. Similarly, you see a product here as well. So when you see such kind of things, you have to, get this thought in your mind that there is a product rule that is getting applied somewhere. So let's see how is, that getting applied here. Let us consider p of x is equals to f of x multiplied by f dash of x. All right. Now if you take the derivative of it, p dash of x is equals to fx multiplied by f double dash of x plus f dash of x multiplied by f dash of x. All right. So this is simply f double dash plus f dash whole square. All right. Now consider p double dash of x. All right, you have to differentiate this again. Let's differentiate this part first. Let us keep f as it is, and we'll differentiate f double dash of x, which will give us f triple dash of x. Now we will keep f double dash of x as it is, and we'll differentiate f of x. So that will give you f dash. So this particular term is getting generated, f multiplied by f double dash. All right, plus we have to differentiate this. So this will give us 2 multiplied by f dash, and the derivative of f dash of x is f double dash of x. All right. So this is 3 multiplied by f dash f double dash plus f triple dash of x. So therefore this function is simply p double dash of x, where p of x is f of x multiplied by f dash of x. So now we know what this function is. So let us go back to the question and see what they're asking for. So they're asking us to find out the minimum number of zeros of this function. So before going to find out the minimum number of zeros of a function, I would like to recall a specific fact about derivatives and the functions itself. So let us say you have a function h of x, all right, and let us assume that h of x has 2 roots. All right. So if you draw the graph of this function, so h of x can be like this, or h of x can be like this. All right. So these are the two possible scenarios that can happen. All right. So in this case, if you check the first case, there is only one turning point, and the x coordinate of this particular turning point will be the root of h dash of x. Alright. And similarly, if you see, there are 1, 2, 3, 4, 5 turning points. So the x coordinates of all these turning points will be the roots or zeros of h dash of x. Alright. So the minimum number of roots of h dash of x that can lie between two consecutive roots of h of x is 1. So there will be at least one root that lies between any two roots of h of x. To be precise, any two consecutive roots of h of x. So this is the fact that we should all have at the back of our minds in order to solve this particular question. Alright, now let us go back and let us plot these points on the graph. Alright, so you have a graph like this. So 0, 0, so at x is equal to 0, y is equal to 0, and 1, 1 it will lie somewhere here, 2, minus 1, so somewhere here, 3, 2, it will be somewhere here, and 4, minus 2, so somewhere here. So they are asking us to find the minimum number of zeros of p double dash of x. So let us find the minimum number of zeros of p of x first. Alright. Okay. So to find the zeros of p of x, we have to find the zeros of f of x and zeros of f dash of x. So first let's find out the number of zeros of f of x. So let us try to draw a graph. Since they are asking about the minimum number of zeros, so we'll start here, we'll go up, our graph will go directly to this point, and again to this point, and to this point. So the minimum number of zeros that f of x can have is 1, 2, 3, and 4. Alright. So the minimum number of zeros f of x can have is 4. So from this particular fact okay, now f of x has minimum of 4 roots. So between every two roots of the function there exists one root of a derivative. So we have discussed it already. So the minimum number of roots f dash x can have is 3. Now let us find the minimum roots p of x can have. So p is simply f multiplied by f dash. So this has a minimum of 4 roots and this has a minimum of 3 roots. So p will have a minimum of 7 roots. Alright. So let's say you have a function like this, x minus 1, x minus 2. This is f of x. And let us say f dash of x is something like this, x minus 3. This has 2 roots, this has 1 root. When you do the product, it will have 2 plus 1, 3 roots, something like that. Alright. Now, we got the minimum number of roots of p as 7. Now, p dash of x. What will be the minimum number of roots of p dash of x? It will be 6. Again, the same concept. Between any two roots of a function p, there will exist at least one root of the derivative p dash. Alright. Using similar concept, the minimum number of roots of p double dash of x is 5. And we have to find out exactly that, the minimum number of roots of p double dash of x. So the answer to this is 5. So the first thing that you have to notice in this question is that there is a product rule that is getting applied here, and you have to figure out that this is p double dash of x. And once you do that, you have to plot the graph and see that the minimum number of roots is 4, and then you have to repeatedly apply the concept of the number of roots and number of roots of the derivative, that particular concept that we have discussed. Okay, so if you have liked this question or the concepts that I'm sharing, leave a like, share it with your friends, and subscribe for more such content. And if you have any queries, comment box is the way to go. A link to my Telegram channel is given in the description, and check out the other videos on my channel.